I bought this other thing from them called the ASRX, which is like their drum machine model. And they said, oh, it's exactly the same, da 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 da. I open it up, and it's like empty. I'm like, well, how can this be the same? It's like, yeah, exactly. It's like, this weighs nothing. And I opened up, and it's like, and I listened to it. You know, I don't know if you've ever done that before, where you listen to one thing or another, and you're just like, this doesn't sound the same. You ever experienced that? Like a cheap CD player, it just doesn't sound very good, you know? Well, yeah, it's the converters, man. There's some science, some technology going on inside there, converting stuff back into audio. There's some stuff happening. So, and yeah, it's not always, you know, so certain stuff has a sound. It's like, you know, plastic cameras are out there, you know? If you're into that, if you're into photography, it's an artistic choice, you know? Not everything's in focus. Maybe that's good. You know, it depends what you're doing. All right. So bits. Each sample that we recorded, right, 44,100 a second or whatever, it's stored as bits on your computer. Bits are ones and zeros. Here's our little binary tour real fast. We have what's called word length. So if we have 1 bit, how many values can you have? 2, 0 or 1. Does that make sense, right? What if I lengthen that? Add 1 more bit to it. It's going to double. Basically, I can have a 0 and a 0, a 1 and a 0, a 1, a 0 and a 1, and a 1 and a 1, right? Are there any other combinations you can think of for those bits? No, 4, right? Add another bit. So we can go from 0, 0, 0 to 1, 1, 1. We can get 8 values. It doubles every time you add a bit, is basically how it works. So each bit of length doubles the possible values. 1 bit would be 2 values, 2 would be 4, 3 would be 8. Basically, it's like taking 2, because each bit can have 2 values. Every time we add that to the length of the word, we get twice as many, right? 2 to the power of bits. So 2 to the 4th power, right? Taking you kicking and screaming back to math class again, right? 2 to the 3rd power would be like what, cubed, right? 2 times 2 times 2, right? 4-bit would be 2 times 2 times 2 times 2. So anybody into video game systems? A little bit? No, not at all. You guys don't play games? Come on. All right, the original Atari, right? What were the graphics like? Requires some imagination on your part. Oh, that's a tank. Oh, okay. Right? Or we're playing basketball. Remember the sound? Right? Not very good sound, right? Mostly, right? So 4-bit audio, 16 values. So it wasn't very, very high resolution, right? How much better was the Nintendo? It was dramatically better. Anybody know what the resolution of the Nintendo was? Some people go, yeah, 8-bit. And they're like, yeah, 8-bit gaming was so great. Well, how much better is it than 4-bit? You want to say twice, but it's not. How much better is it? 2 times 2 times 2 times 2 times 2 times 2 to the 8th power. It's 256 values compared to 16. Is that a big jump? Yeah. And all of a sudden we got all kinds of more interesting games and so forth. They're much more like the arcade kind of stuff, right? The 16-bit revolution. Anybody with me there? Got a couple guys a little older. That'd be the Sega Genesis, the Super Nintendo, right? How much better than the original Nintendo? Dramatically better. 16 bits is going to provide what? Instead of 256 colors, now what? 65,536 colors. So dramatically better. The games are now in 3D. We get all these different levels and stuff like that. New game systems, they went from like 32 and then Nintendo 64 and so forth, right? Just even going to from 16-bit to 24-bit, how many more values? 2 to the 24th power is 16,777,268. Right? It's like massive, right? Big, big changes. Just 1 bit does what? Doubles, right? Every time we add a bit. You okay with that idea? 'Cause that's going to be a big deal when we start talking about audio. I use that analogy of talking about audio being like photography. PCM audio to me is very, very much like digital photography, right? In digital photography, our sampling rate is what? We call them pixels, right? How many pixels we have, right? So what's a common camera have today? Okay, 8 megapixels, 12 megapixels, right? The first one I bought was not even a megapixel. It was like under that, right? It did 640 by 480, I think, or whatever. It was from Epson, known for optics, right? It was from, I bought it from Staples or something like that, right? Known for cameras, right? So it was a total piece of junk. And I returned it, right? Why? Because it looked terrible, right? Now, if I stuck my head in the ground and said, oh my God, you know, digital photography is going nowhere, what's happened? Oh, it's changed dramatically in 12 years, right? All this stuff has changed, right? And so every one of those little samples, though, right? The little squares that make up our image, the pixels, right? You guys okay with that idea? They get stored in your computer, right? Stored in the camera. The light to dark ratio is stored as what? Well, bits. Dynamic range. What's dynamic range in photography? Light to dark. Does that make sense? What's dynamic range in audio? loud to soft. Does that make sense? Kind of similar stuff. We're recording energy here, right? Instead of light energy, recording sound energy, right? What if you had only 1 bit to record your camera? What are you going to get? Yeah, black and white. We got a 1 or a 0. And so now I got basically my dog. All things that were sort of dark are just going to be a 0 and going to be black, right? Well, it's kind of a dark gray. No, sorry, we don't have that. You're black, right? I'm kind of a light gray. No, sorry, you're white. That's all I have. 1 or a 0. Here we're going to round you, right? If I add another bit, I store with 2-bit resolution, I'm going to get how many? 4 levels. Does that make sense? Does that make a big difference? Yeah. I mean, maybe you've seen this before in like a JPEG, right? Where you can see like a dark gray, a light gray, and, you know, it kind of looks kind of weird, like a sunset where it's like gradient, you know, kind of see the steps between it, right? What if I add another bit? What's going to happen? Double again, right? That makes sense? So I'll get 8. From 0, 0, 0 to 1, 1, 1, I'll have from black to white with all these different kind of grays in between. Make sense? I'm just trying to draw an analogy here between what we're going to do. Okay, so 4 bits would double it again. Does that make sense? 2 to the 4th power. We'd have 16 degrees of dynamic resolution. Every one of those samples that we have will be rounded. Does that make sense? Every sample that I take is going to be rounded to a number. I got to give it a number. With 4 bits, 4-bit audio, which did exist for a while. It's really awful. Anybody have a toy called the Yak Back toy? It's like a little handheld sampling thing. You'd like yell in it and it would like try to play it back. It's awful. Anyway, 4-bit audio. So every one of these little samples, like this little dot right here, basically I don't have that resolution. You know what? I'm going to make you 10000. You know, this one, you're not quite there, but I'm going to make you 1100. This one, I'm going to make you 1101. So I'm doing what? I'm rounding. There's a term for that. In my MIDI thing, we talked about something called quantizing, or actually we didn't really get too much into it yet, but basically changing timing. Here, we're quantifying, right? I have 16 values. Here you go. You're closest to this one. Boom, rounding. Is that going to change what the audio sounds like? Yeah. If it rounds it, we're going to all of a sudden get a very different looking waveform, right? Because especially the quiet stuff, does that make sense? There's actually quite a few degrees here for the loud stuff, but when we get quiet, there's not enough degrees to describe it. We're going to round you into one or the other. You know, it's like, dude, you're black or white. That's all I got left. And you get this kind of weird problem with digital audio. It's called quantization noise. It sounds like it's really strange noise on the bottom of everything. So, okay with the concept of quantifying. Kind of like audio, right? So how many of you are familiar with analog setting levels on a tape deck or something like that? I guess it's rare I talk about cassette decks anymore, but I'm sure you've all touched one at some point, right? How do you set a level? Where do you want to set it when you're recording? On the analog side. Close to 0, right? Hovering in that range, right? Does that make sense? How's that different in recording digital? Yeah, right? If you set your level here at 0 and you think this 0 equals this 0, this is a totally different 0. There's room above this 0. In fact, this room is basically, we call it headroom, right? We can record above it, right? So my average level is going to hover around here. You know, it's like, this is a good idea. Hang around here, right? All right, my average level bouncing within here. What's the rule here? It's like The Price is Right, right? Do not go over 0, right? Get as close as you can, but don't go over. So people get paranoid, and they're like, I'm just going to record down here because I don't want to clip. What happens when you clip? Basically, there's no more signal information available, so it simply just lops up any dynamic range information, just flattens it out. To compare it in photography, if I had a camera and I got really close to you, I took a picture with the flash on, what are we going to get? This white ghost, right? Can I fix that? Kind of like lower it down. I can get a grayer ghost, but all the detail's been clipped off. White is clipping in digital photography, right? If you set your camcorder too bright, you know, it's just like snow, right? We're gone. All right, what's the opposite? Not if it's too dark, right? I take a picture in a dark environment and I get this weird, murky image with all this noise and crap down the bottom. That's kind of basically the same thing here, right? Here we're used to this idea of having this range of signal to noise, basically from where it distorts, which sometimes could almost be pleasing if we were doing it correctly, to this hiss, this noise floor down here, right? This noise floor to distortion, we called it a signal to noise ratio, this amount of room available to record.